Day 560 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 111, minimum depth of a binary tree. The difficulty level is easy, so you already know we're going to keep the solution as simple and easy to understand as well. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. Given a binary tree, find its minimum depth. The minimum depth is the number of nodes along the shortest path from the root node down to the nearest leaf node. Note, a leaf is a node with no children. All right, y'all, so that sounds simple enough, but let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So, in our example 1, we have the input root equals the binary tree 3920, null null 15 7. The output is 2 because the minimum depth is 2. So it says right here, the minimum depth is the number of nodes along the shortest path from root node down to the nearest leaf node. So the shortest path from the root node, which would be this 3, down to the shortest, or down to the shortest path would be down to this 9, where the 9 has no children, right? It says the leaf node is a node with no children. So the shortest path from this 3 to this leaf node would be 2, whereas we went from this 3 to this leaf node, it would be 3 because we go 1, 2, 3. And similarly with this leaf node, it would also be 3 because we go 1, 2, 3. But here we only go 1, 2, and that's the shortest path, so that's why we return 2. So just in case that didn't make sense, let's look at example 2. Example 2, our input root is an array of integers 2, null 3, null 4, null 5, null, and 6. This time the output is 5 because that would be the shortest path. They didn't give us a picture, but they're pretty, they get these outputs right, so I'm gonna just trust LeetCode on this when they say that the answer is 5. That's the principle of how the question works. I hope that makes sense to y'all. Just in case you don't understand this, we could go through how this actually refers to the binary tree. As you can see, this right here is the head. This is the root node 3. Then the 3 has 2 children, right? It has a 9 and a 20. So that's where this 9 and this 20 comes from, right? Boom. Then as you can see, this 9 doesn't have any children on the left or the right, so that's where this null comes from. No children on the 9 on the left, no children on the 9 on the right. Then as you can see, this 15 has 2 children. This 20 has 2 children, this 15 and 7. So that's where this 15 and 7 comes from right here for the 20, the child nodes to the 20. So that's just how that works, just in case you didn't know. And now that we understand the question, y'all, let's get into the fun part, the actual solution. Solution is not that difficult at all, so let's get into it. The first thing we're going to do is we're going to see if the root node is nil, then we could just return the minimum depth is 0. So we could use a guard statement for that. We could say guard let root, it should be root equal root, else we can open up the brackets and we can return 0. Boom. Then we're going to come underneath that and we're going to initialize a variable to track the current depth level. So we're going to declare a variable called depth, and we could just set that to 0 to start. Now we're going to use a queue or an array for the breadth first search, and we're going to start with the root node. So we're going to declare a variable called q, and we'll just set that equal to an array of root. Boom. Then we'll come underneath that, and we're going to continue traversing the tree level by level. So we're going to say while exclamation point q dot is empty, which means while it is not empty. That's what that exclamation point means. First, we're going to create a temporary list to hold the next level of nodes. So we're going to declare a variable called level, and we're going to set that equal to open up the square brackets and pass in tree node. Boom, come outside the square brackets, put the parentheses just like that. Then we're moving down one level in the tree by saying depth plus equals 1. Boom. Then we're going to iterate through all the nodes at the current level by saying for node in queue. We're going to open up the brackets, and if a node has no left or right child, that means it's a leaf. And since the BFS or the breadth first search finds the shallowest node first, this is the minimum depth. So we're going to say if node dot left equals nil, and two and sides, node dot right equals nil. Then we can open up the brackets and we can return depth. Boom. Then if a left child exists, we're going to add it to the next level's list by coming underneath this. And we're going to say if let left child equals node dot left, we're going to open up the brackets and we're going to say level dot append, open up the parentheses, we're going to say left child. Boom. Then if a right child exists, we're going to add it to the next level's list by coming underneath this, and we're going to say if let right child equals node dot right, then we're going to open up the brackets and we're going to say level dot append, open up the parentheses and pass in right child, just like that. Boom. Then we need to move to the next level by replacing the cube with the collected children. So we could come right here and we can say q equals level. Boom. And now finally we need to return the depth by coming right here, and we could just say return depth. Y'all, that's all she wrote. Let's give it a run. Make sure it runs properly. When we have an error, it says cannot find node in scope. So let me see where, oh, we need to put an E right here. So let me run this again. Let's see if that works. It's accepted, so let's go ahead and submit it. Make sure it's still accepted after we submit it. Let's see. And look at that, y'all. 0 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. So before we go, make sure you get one more look at the code. This is the top part. This is the bottom part. And yeah, y'all, with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.